Okay, hi guys. So I'm gonna just quickly explain how the moss generation works using the yaw and pitch value input. So the attribute wrangle that's responsible for telling us which points have moss on use a 3-vector value. So that's like 1, 0, 1 or 1, 1, 1, and these correspond to a yaw and pitch value, which are a bit easier to work with, and that's what I would expect people to more generally understand, is that these are easier for you to make than trying to figure out the 3-vector that correlates to the angle that you want. And it means that you can just control the slider, and you can see that our yaw value rolls around, well, yeah, okay, I'll say that. The yaw value is around, so left and right. And then the pitch value is up. So right now that's looking up and down. That's looking down, yeah. So if we put our values at 0, you'll see that it has generated our moss perfectly looking at the tree from this angle. And if we look down, and maybe even if I got this out, okay, so it is perfectly pointing in the x direction because we've given it a value of 0, 0. So that's going to return us a 1 on this axis, so let's say here, and then 0 upwards and 0 around. And we should be able to see that here. So we've got our flow direction 1, 0, 0. So 1 on the x, 0 on the y, 0 on the z. So I've drawn a little diagram so that we can better understand this. So we've got these values here. So let's see if we can do the maths real quick. So I'm going to give it a new value. That is going to be something that I can work with. So 45 on the yaw, and then 60 on the pitch. Okay, so that is slightly upwards and rotated, so maybe this direction. Okay, so if we come here, let's just do our xy values. So xy values, I could have changed the colors, but what number did we end up choosing on the pitch? 60. Okay, let's go back here. That out. We've chosen 60 here. So we want to figure out what this point is there. So if we're looking at it from this angle, it's making this point, and then you also rotate around by our yaw value, which I think it was 45. So you've got 60 here, 45 there, and then if we're just using the xy, so that makes this triangle, and that makes this triangle. So we're going to focus just on this one. So we want to figure out this is called, so on your triangle you have your H for hypotenuse, O for opposite, and A for adjacent. And we were taught so, ka, and then that's all we need. But then the last one is toa. So sine theta equals opposite over adjacent. So in this instance, sine 60 equals our O and A, because this one is opposite to the angle and this one's adjacent. So sine 60 equals O over A. Now we know sine 60 equals root 3 over 2. Okay. Now it's a different. Let's see what it's given us in Houdini. So we've got 60 pitch value, and our flow is 0.35, 0.86, 0.35, and we got root 3 over 2, which I think would give us values. I think off the top, without a calculator, I'm not going to be able to figure that out off the top of my head as an exact decimal, but trust me, that's how the maths works. So we've got here the direction of x. So this number that's being calculated is actually cos pitch. So remember, we used sin. So cos pitch multiplied by cos yaw, and that's given us this x direction. So if we were writing that here, that is the pitch is 45, so cos 45 times cos 60, which here we have cos 60 is a half, times cos 45, which is 1 half times 1 half root, which then equals 1 over 2 root 2. Yeah. Which is going to give us this value here, so 0.35. And then direction y, so that's just sine pitch. So that is sine 60. I presume this is root 3 over 2. Root 3 over 2. Let's quickly look that up. See, I've been doing my research. Root 3 over 2 as a decimal. Hmm. 0.866. Yeah, there you go. So we calculated it right. And then our direction on the z-axis is cos pitch sine yaw. So we already know that cos pitch is a half, and then sine 45 I think is okay. So we've got cos pitch. So it's the same value. Did we already know that? Yeah, same value. So I hope that clears up how this one works and how the maths works. And I will see you in the next video. Thank you.